All right, for the second half of 7.5, we're going to talk about the geometric mean. Before I do that, let's talk about the arithmetic mean. You guys are very familiar with the arithmetic mean. For example, let's say I wanted the mean between 5 and 7. You add them together and divide by 2. You get 12 over 2, which is 6, right? That's the arithmetic mean. This is something you're very, very familiar with. You've also probably done it with more numbers, right? We could say like 2 plus 4 plus 6 divided by how many numbers? 3. And you would get 12 divided by 3, which is 4. So that's the arithmetic mean. You divide, or you add the numbers together and divide by the total numbers, okay? Well, we have another type of mean. It's called the geometric mean. And the geometric mean really comes from similar triangles, from proportional parts. It's the positive square root of the product of two positive numbers. Well, what does that mean? Well, it starts off like this. That x would be the geometric mean of these two numbers, a and b. But if you cross multiply, you'd get x squared times or equals ab. And then, remember, if you want to get the x all by itself, you'd have to take the square root of both sides, leaving you with just an x over here and the square root of ab. So this is the formula that you are going to use most frequently when calculating geometric mean. And sometimes the way you'll see me write it, instead of an x there, is I'll write g equals the square root of ab, meaning the geometric mean equals the square root of a times b. So let's just show you how I'd calculate that real quick. If I want the geometric mean of these two numbers, I'm going to just say that g equals the square root of 15 times 20. So first, I got to figure out what 15 times 20 is. It's 300. So I got that g equals the square root of 300. And then I got to see if I can simplify that, right? Is there any perfect squares inside 300 that I can pull out? Well, I know of one. Isn't 300 the same thing as 100 times 3? And 100 is a perfect square. So I could take the square root of 100 and get 10, and then I would leave the 3 inside because it is not a perfect square. And so there's my answer. Again, 10 rad 3, or 10 square root 3, or 10 times square root 3, however you want to say it, there's a decimal number that you can represent that with, and sometimes they'll ask for the decimal, but most often all we want is this exact number. If you want the decimal, just put 10 times square root 3 in your calculator, and you'll have it. Okay, I want you to try to find the geometric mean of these two numbers, or these two pairs of numbers, so 4 and 9, and then 6 and 15. So I want you to pause the video, give that a try, and then unpause it when you're ready to check your work. Okay, so 4 times 9 underneath the square root, that's 36. The square root of 36 is 6, so the geometric mean of 4 and 9 is 6. How about 6 and 15? Well, 6 times 15 is 90. The square root of 90 is not a perfect square like this one was, so instead I'm going to see if I could break it down to a perfect square, where I get 9. 9 is a perfect square, and 10 is not, so the square root of 9 is 3, and I just leave it as 10, so 3 rad 10. So these are the geometric means of these numbers. Okay, geometric means are always just going to be of two numbers. And now we're going to talk about how we could apply this in right triangles. Now don't be overwhelmed. This little map should help you, but basically we have some relationships that use the geometric mean in geometry. So in a right triangle, the legs and the altitude is this height right here in the center, it's got to make another right angle, are the geometric means of other parts of the triangle. So to know what parts, that's why we got this little diagram here. So for example, the height, the center line here, is the geometric mean of this distance and this distance. While this leg, B, is the geometric mean of this distance x and this whole hypotenuse c. And similarly, A is the geometric mean of y, this distance y, and this whole distance c. So once you cut up a triangle like this, you should be able to find all the other parts using the geometric mean. And again, the formula that I have here, this is, if you look at it, this is really using this part of the formula, but usually you don't use that. Usually you just use, and I'll write it here for you, instead I would use h equals the square root of xy. And you could really use either one, it's okay, but this one is usually a little bit quicker. And here I would write a equals the square root of yc, And finally, b equals the square root of xc. So all of those are just another way of writing that same formula. But you're going to want to keep this chart handy, as this is going to really help you on all the problems that might involve the geometric mean. It's just a real helpful tool for a lot of these problems. So let's take a look at example number 4 here. It says use the diagram above to find all the missing segment lengths in ABC. Well, there's a few missing segment lengths. I'm going to fill in these letters with the ones that are missing here. So it looks like we're missing this side, which we will call side A. I'll do this all in blue, A. It looks like we're missing this height here, which we'll call H for height. It's also known as the altitude. And it looks like we're missing this segment here, which the diagram calls Y. Okay. At least we have some way of talking about it. I mean, we could talk about it as CD and CB and DB, but I like just saying A, H, and Y. Makes the math a little bit simpler. All right, so we got to figure out what we know here. And we do have 2 parts. Anywhere where we have 2 parts, we should be able to find the third part. For example, I have this part and this part. So that looks like I'm going to be using the green rule here, right? That B is the geometric mean of X and of C. And so I can use either one of these equations. For the sake of simplicity, I'm just going to use this one that I told you guys I'll use most frequently. So I know that B, and let's just write it, B is going to equal the square root of XC. Well, according to my chart, B is 5. So I know that part, square root. And I also know the X part. The X part here is 2. So 2. But I don't know this total distance C. In fact, I may want to just mark that, C. So I'm just going to put a C there. Well, now I'm just going to solve for C, and it's not as hard as it looks. To undo a square root symbol, I simply square both sides. Because remember, the square and the square root, these are opposite functions. So that cancels these things out. And 5 squared is 25. So I get 25 equals 2C. And now I'm just going to divide by 2, and I get 12.5 for my C. So let's go back to my diagram. And I now know that C here is 12.5. Okay, well, this should be really helpful because now you should be able to find Y really easily. Think about it. If the whole thing adds up to 12.5 and this distance is 2, what's left? Hopefully you see that really quickly. It's just 12.5 minus 2, so this is 10.5. So we actually got 2 parts for 1 there. That's kind of nice. So I'm going to do one more with you, and then I'm going to let you do the last part. Let's do H together. We're going to find H. So according to this drawing, H is the geometric mean of X and Y. Well, I now know X and Y, or the X and Y part. So I can do that. I'm going to do it in red. The formula that we have is that H equals the square root of X and Y. That's the geometric mean formula. And the H is unknown. I don't know the H. But I do know that my X value now, the X value from this drawing, is 2. And the Y value is 10.5. All right, so let's just solve this out. H equals 2 times 10.5 is 21. So H equals the square root of 21. Now, I don't think this is going to simplify any farther, because if I was to break this down, what multiplies up to 21? Well, 3 and 7, so I can write this as the square root of 3 times 7, but neither one of these are perfect squares, so this isn't going to simplify. So I don't need to do that, and I am done. I can just leave my answer just like that. Okay, H equals the square root of 21. Now, there is, of course, a decimal equivalent of that, but again, we don't really care about that unless they ask for it. Otherwise, we're just going to use it, leave it in exact form. Okay, so the last thing we're looking at here is side A, and I want you guys to solve that. You can see side A here is the geometric mean of Y and C. You know both Y and C, so I want you to go ahead and give that a try. Pause the video, give it a shot, and then unpause it when you're ready to check your work. All right, so I used the formula for the A one. I used this one, A equals the square root of y times c. A equals square root of y times c. I plugged in the y, I plugged in the c. Y times c, or 10.5 times 12.5, is 131.25. And so I got A equals the square root of 131.25. Now, most likely in a question like this, if you're taking the square root of something that's already a decimal, they're probably going to want a decimal answer. So I would, at this point, go in my calculator and type in the square root of 131.25. And since they didn't specify, I'm just going to round it to 2 decimals, and I'm going to say that A is approximately 11.46. That's rounding up. Okay. And that's just because it's already a little bit messy here with the decimal, so I'm guessing that they're probably going to have me round anyway. So 11.46 is the answer for A. So anyway, we found all the distances, found them exact and decimal versions of A. And so we did that all using the geometric mean. And again, I would recommend keeping this chart handy with you in class while we're doing these problems, because this is going to help you and save you a ton of time if you have this chart. All right, I'll see you guys on the next video.